Howdy Huskies, it's Mr. Knott, and you're back for another fun video with me. Hopefully this one goes much shorter than the last one. That last one took a day. All right, let's hit with those review questions right off the bat and make sure we're all gravy. So it says state the multiplicity of a zero. So in the 0, 8. So I'm just going to focus on just that one right there. So obviously we can see it's to the 3. So that means that you're going to have a multiplicity. I'll just put mult of 3. And that 3 is an odd number. So if you remember, as to the previous video, if it's odd, it's going to pass through. And if it's even, it's going to bounce. So in this case, because it's odd, it's going to go ahead and pass right on through at positive 8. Something like that. Cool? All right. Next one says find the zeros. So when we're finding the zeros, we're going to go ahead and factor. Excuse me. So if you want to refer to a previous video on factoring, feel free to YouTube that bad boy. For this one, I'm going to use what's called U substitution because it's an x to the 4th, but it's only a trinomial. So what I'm going to do is I'm going to say U is equal to x squared. Okay. So obviously I can plug that right on in here, and then I'm going to have 2 of those with x to the 4th. So this is now going to become U squared minus 6U plus 8. Now we can factor this pretty easy. So we say, all right, make your x. What 2 numbers multiply to that positive 8? And then they add to a negative 6. That goes on the bottom. So that is obviously going to be negative 4 and negative 2. Now we have then U minus 4, U minus 2. Well, we said U was dun 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 x squared. So I'm now going to put that back in. Cool. So now that it's back on in, I'm going to go ahead and say, alrighty, this is a perfect square. So x minus 2, x plus 2. And then that second one's a perfect square, but I want you to think about it for a second. What 2 numbers that are exactly the same are going to make 2? Loading, loading. And this one's a tricky one. It is going to be root 2. So x plus root 2. X minus root 2. That was a little saucy. I dig it. I dig it. Alrighty. And the last one is state the end behavior. So once again, when we're looking for end behavior, we're going to look for that degree. So the highest exponent, which in this case is going to be 3. So 3 is odd, which means they're going to go in opposite directions. And it's negative, so it's going to go ahead and end low. So it's going to be something that looks kind of like that. So our end behavior on the left-hand side, so remember this is the left arrow. So we say as x goes to negative infinity, f of x is going to go up because that arrow is pointing up. So we say positive infinity. And then on that right arrow right there, we're going to say as x goes to positive infinity, which is the right-hand side, f of x is going down. So we're going to say towards negative infinity. Or we could use our arrows. Some of you probably went, I like that way. Either way is fine. Alrighty. Ladies and gentlemen, our nice review is going to set us up for success. Our goal today is all about that graphing. We're going to be graphing. So we're going to need some of those end behavior rules because that's going to help us graph without a calculator. Dun, dun, dun. Yes, calculators are amazing. Yes, you need to know how to do it without a calculator, or else this would be the shortest video ever because it would be plug it into the calculator and do your thing. Now, we're going to have a small little piece before we jump into the main goal, and that's going to be this intermediate value theorem. And what that is basically saying is, let f be a polynomial of the function where if a and b have opposite signs, so let's break that down. So one is negative and one is positive, then there must be one value c in between a and b that is a 0. So let's break it down. Break it down now. So if a graph is cruising along, it has to cross the x-axis if it was negative and now it's positive. So I'm going to say, hey, in between those 2 values, did it cross the axis? If it did, then our sign should be different. Okay. If I pick 2 values and they're both positive, well, clearly it doesn't cross them. Okay. So let's go ahead and take a look. So on example numero uno, it's saying, is there a real zero? So is there a zero, a real number that we can see in between -3 and -2? So you're just basically going to plug in a -3 and then a negative, and then we'll compare those signs. All right, -3 on in. And since we have multiple x's, it goes into multiple spots. So remember your PEMDAS, so -3 cubed minus 10 times -3 plus 9. So there's going to be 27 that's negative. And then we're going to go ahead, 3. There we go. I was like, why am I getting a number that I thought was a little bit different? So this is going to be 3 times that, so that's 81. Sounds a little bit better. That's negative, plus 30, plus 9. So when all is said and done, I'm going to get a -42. Now, it doesn't number what the value is. It matters that that is a negative. So if it's going to have a 0, this -2 better give me a positive answer. If it is also negative, it did not cross. So let's give it a shot. So 3 times -2 cubed minus 10 times -2 plus 9. So this is going to go and be a -24 plus 20 plus 9, which is a positive 5. And again, the kicker is not that it's a 5, but it's a positive. So as we can see right here, there is a sign change. So because there is a sign change, we have verified that there is indeed a 0 in between those two values. Do we know what it is? Not by this theorem. The intermediate value theorem is just saying, hey, there's a sign change. There must be there. All right. So we're going to go ahead and be graphing today. So here are some graphing tips and tricks. So if a polynomial, I'm going to erase this so we can see this clearly. Again, pause this if you need to write down this stuff, if it's good stuff. Pause, play. So if a polynomial has a degree of n, so if it's an x cubed, that would be 3. If it's an x squared, that's 2. The most turning points, meaning when the graph switches directions, going from increasing to decreasing, is n minus 1. Now, I want to focus that is the most. So let me give you an example. If you have a graph that's x to the 4, our degree is 4. It could look a couple of different ways. Let me do this correctly. I apologize. It could look like this. It could look like this. Or it could look like this. So in this case, I would have 1, 2, 3 turning points, 1, 2, 3 turning points, or just 1. So I want you to note, ladies and gentlemen, that it is n minus 1 being the most. Not mean that's that many is going to have. The most. Cool? Alrighty. So some other things that you want to do is check for symmetry. This is what we're going to call with symmetry. Okay? It looks the same. It looks pretty. This one, not so much. Alrighty. Find the intercepts. Okay? AKA, that is our C. I almost wrote down the wrong thing. So our y-intercept is our C, or our constant. Let me just write constant, because it's not always the C depending on how we write it. So our y-intercept is our constant. There we go. And our x-intercepts, which are super important, are the zeros. The zeros are going to be what we're going to be looking at most in the next couple of days and videos. So I'm going to star that bad boy. Identify the end behavior. So if I were to go ahead and, just because I made the other video, I would know. If we go all the way back up here, review that end behavior video day, previous day, because this is going to help you dictate what it's going to look like as well. All right. So the next thing is identify this crazy little theorem right here. Okay. So if that k is even, then it touches to the x-axis is bounces. We talked about that in the previous class. So it would be something where at that 0, it stays on that side. Okay? If it is odd, remember we're looking at just that k value. So if that k is even, bounce. If that k is odd, that's going to pass through or crosses. All righty. And if k is greater than 1, okay, that means it's just going to be, the more we have, it's going to flatten. So this is just asking right here, it's multiplicity. Look at that. It's going to help us. And it says plug in additional points to find the general shape if you have time to do so. Okay? We are not going to get too crazy into that aspect, but if you want a good idea, you should probably put in multiple points, because looking at just the zeros, sometimes we're not sure if it's going to be one of those, how it's going to look. Okay, so plugging in different points gives us the for sure look. All righty. So, ladies and gentlemen, boys and girls, number 2 here in our example. So, the first thing I want you to go ahead and look at is going to be the degree and the leading coefficient. I'm just going to call it the LC. Okay. The second thing I want us to find are those intercepts. So remember, if you have a constant, that's going to be your y, and then your zeros are going to be your x-intercepts. Now, to do that, ladies and gentlemen, boys and girls, that's going to transition into something that we'll see right at the start, is you're going to have to factor to find those x-intercepts or those zeros, okay? So the rules for factoring for today, the first thing I want you to do is find a GCF. Then I want you to do grouping, or we can go ahead and do an X. Okay, the X method we kind of went over in our review questions. Okay, and then last but not least, you're going to look out for perfect squares. Those are my tips and tricks to help us out. Okay, now with those, obviously, we got to look at the multiplicity because of things like flattening and stuff like that. We'll get there as we see them. So in our first one, this has got 4 terms, 1, 2, 3, 4. Okay, so again, we're graphing these by hand. We're not using a calculator. Feel free to use a calculator to check your work, but you're going to need to know how to do this by hand. So 4 terms means grouping. Group the first 2, second 2. This has an x squared in common. That's got a -1 in common because they're both negative. So this is x squared, x plus 2, -1, x plus 2. Then we're going to say that they have an x plus 2 in common. So this becomes x squared minus 1, x plus 2. Now, your spidey sense should be going off because we have an x squared, sports fans. So that means that that's probably going to be a perfect square, and in this case it is. Again, that's a negative, and that's a 1. Perfect squares have to have that negative in between them. So this is going to turn to x minus 1, x plus 1, x plus 2. If you're having issues with perfect squares, that's a YouTuber. YouTube perfect squares. You can take 20 seconds and you'll feel a little bit better. But check this out. These are our factored form right here, which is wonderful. But you have to set them equal to 0 to find your zeros. So this is going to give me x equals 1, x equals -1, and x equals -2. So 1, -1, 2. Cool with that? Alrighty, so we have the zeros, which is great, but I also talked about, hey, look at some degrees and some end behaviors. So let's look at this. This is an x cubed. So that's obviously going to be a cubic, which is important, but that is going to be an odd. So remember, that means our end behavior, I'm going to just say my EP is going to be opposites. And because that leading coefficient is a positive 1, my LC is 1, it's going to go ahead and end high. So that means my arrow is going to be up here, and then this arrow is going to be down there. We all gravy? Now, what are we doing in between? Well, that comes back to the multiplicity. So this is a single, single, single. So that means they're all going to pass straight on through, no bounces. Okay? Now, the last thing I'm going to do is, because this is already in its standard form, that is my constant right there, that -2. So that's going to give me -2, just one more easy point to find. So let's go ahead and put this together. So I know that it's going to go start low, pass through, connect, pass through, and there's your graph, and it looks pretty gosh darn good. Cool? Alrighty, so let's go ahead and go to number 2. So it doesn't matter if you start, like last time we started factoring, this time just for funsies, we'll go ahead and start with our degree and our leading coefficient. So this is an even degree because it's an x to the 4. So that means my end behaviors are going to match. And because my leading coefficient is negative right here, they're match going down. So that means if I go ahead, I know that both of my arrows are going to end low. And so I'll just put them down here in general. And that's kind of the idea when we made that video last time with here just looking at these arrows. The idea was we were going to just draw them in and then worry about what's in between later. So we drew them in. Now it's time to find out what's in between. So now that we have those in, let's factor. So like I said at the beginning, we're going to start with a GCF. So they both have an x cubed and a 2. Okay. Now I'm a fan, because this is a negative right here, of taking out a -2. So this would be -2x cubed and then x minus 4. All right. So remember, everything with an x is what we care about for multiplicity and zeros. So I don't care about the 2, but I do care about the x cubed and the x minus 4. So this x cubed means that since there's no other numbers, there's 3 essentially zeros. And then over here, if I set that equal to 0, I'm going to get 4. So 1, 2, 3, 4. Cool with that? Now, with our multiplicity of 3 right here, ladies and gentlemen, sorry, I meant to circle that with a different color. Okay, so here with a higher multiplicity, remember, it's going to flatten. Okay, so let's go ahead and plug in our zeros. So I have a 0 here at 0, and I have another one here at 1, 2, 3, 4. You with me? So this graph is going to cruise on through. And I'm going to go ahead and say it flattens a little bit. This is going to be tough to do because it kind of flattens like this and then passes through. Because again, this is an odd. We have odd number of zeros. We're going to pass through. We're not going to bounce. And then I have another odd with the 4. So I'm going to go ahead and pass through and then boom. Now, is this an exact science? No. We're doing this by hand. Should you probably go back and do some extra points? Sure. But as long as we have an idea of what's going through, we're good. Okay? All right. Now, number 4. Number 4 is already factored for us. Okay? They're trying to go ahead and confuse us a little bit, but we are not going to be confuzzled. Okay? So I'm going to go ahead and I'm just going to mosey on down to this and write it down here so I have a graph right next to it. I don't know how that sort of page break happened, but it is what it is. All right. So 3 zeros. So we're going to have a multiplicity of 3. So we're going to have a different color, Mr. Naughton. Let's do this. I'm going to have 3x equals zeros. Again, multiplicity means it's going to be 3. So it's going to pass through and it's going to be flat. So at 0, pass through and flat. Then I have a -1. So when I solve that, I'm going to get +1. And again, it's going to pass through. And then here, I'm going to have a -4. And it's going to pass through. It looks like a Y. Let's fix that. Boom. 1, 2, 3, 4. Cool? Alrighty. So, ladies and gentlemen, boys and girls, let's take a look at this, because this is why this one gets a little funky. I need to use my end behavior to help me. Let's look at my degree. So in this case, I have something where I don't know if I want to double distribute and FOIL this back out to find out what it actually is. That doesn't look fun. Okay, so let's look at how many zeros I have. So I have 1, 2, 3, 4, 5. So that means my degree is 5. Okay, what is my leading coefficient? Negative. So this is odd and negative, which just means it's going to end low. So my arrows are going to start high up here, and I'm going to end low down there. Okay? So let's take a look. I'm going to go ahead and pass through, come back up, pass through, come back down, pass through, and boom shakalaka, there we go. Booyah. Nice and easy peasy lemon squeezy. Again, you should probably use more points, but it is what it is. Alrighty. Let's have you try this next one. This one's a good one. You're going to have to use some U substitution like what we did in our review question, and then try to graph it. So I'm going to pause for a second, let you try, see what you come up with. All right, hit the play button. So I had x to the fourth minus 5x squared plus 4. So let's use that U substitution. So U is equal to x squared. So again, that's to the fourth, so I have 2 of those. That's x squared, which is just a U, and then plus 4. Factor it because it's got 3 terms, 4, negative 5. So that's going to be a negative 4 and a negative 1. So we're going to go ahead and have U minus 4, U minus 1. Well, what was U again? U was x squared. So then we get x squared minus 4, x squared minus 1. Spidey sense should be going off because those are x squareds. Look for perfect squares. So x minus 2, x minus 2, x minus 1, x, pluses, excuse me, because they're perfect squares. I should have a minus 1 and a plus 1. Excuse me for that. So, solving those, I'm going to get x equals 2, x equals negative 2, x equals 1, and x equals negative 1. So, these are all pass through. All of them are pass through. Cool? So, if I put in my dots, boom, negative 2, negative 1, 1, 2. Let's go back to the beginning. This was an even degree. The leading coefficient is a 1x squared. That is positive. So they're going to match, and they're both going up. So arrows up, arrows up. Let's go in between. Now we finally have a constant again. Notice our constant right here is a 4. So that's going to be our y-intercept. So because it's easy, I'm just going to use that extra point. And then go down, up, connect them all together. Boom, shakalaka, there we go. Alrighty, now we told you how to do them by hand. It's now time to do it via calculator. So I'm just gonna go ahead and pull out my graphing calculator that I have. It's gonna take a second to load up because that's what it does. Woo! It is having super fun here. So whenever you're going to graph something, you're going to go hit y equals, okay, and then literally just plug it in exactly the way it looks. So this right here, right where it says link, that's the x that you want to use. Maybe if I close this and do, that's my daughter. Let's try this again. Huh. This is like super giant calculator. I apologize. So y equals, and then I'll use the technical difficulties. Please pause. All right, I think I fixed my technical difficulties. We'll see. Thank you for hanging out for 2.7 seconds. So again, you go to y equals, which is the button on the top left. And right next to the alpha button is going to be the x that you're going to use. So parentheses, x minus 2, x plus 3, x minus 1, and then hit graph. It should be a nice, pretty boom. Beautimous. Beautimous. You can see our zeros. Everything is nice and easy peasy lemon squeezy. Okay? You can see our arrows right in here, or zeros right in here. And you can see this is an end behavior, and this is an end behavior. Notice it's ending high because I have 3 zeros, and that's odd. Cool? All right, one last one here. Clear out what you had before. So 6x, and then I'm going to use the up arrow. It's called the caret right above the divide sign. For the 3, then hit the arrow to come back down. Minus 9x minus x to the 5th. Notice that the x to the 5th is my biggest exponent, so even though I put it at the end, it's going to take control of this graph. So if I hit graph, boom. Look at that, going in opposite directions because your end behaviors are opposite due to the odd nature of the degree. So, ladies and gentlemen, hopefully this helps. Feel free to watch it again. Wasn't nearly as long. Hey, I shaved 4 minutes off. Keep this party going. Have a wonderful day, sports fans. We'll see you later.